Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is the determination of empirical and molecular formulae by the combustion method. Let's begin. A known MASS of an organic compound is genuinely burned completely in excess oxygen, converting every carbon atom into carbon dioxide, and every hydrogen atom into water. These two specific products are then genuinely captured separately, water absorbed by anhydrous calcium chloride, and carbon dioxide absorbed by potassium hydroxide solution, and each absorber's own mass increase is genuinely measured precisely. From the measured mass or carbon dioxide produced, you genuinely calculate the original mass or carbon it came from, and, similarly, from the water's mass, you calculate the original mass or hydrogen. Any remaining mass, compound's total mass minus carbon minus hydrogen, is genuinely attributed to oxygen, if that's the only other element actually present. From these measured masses, the percentage composition of each element is genuinely calculated, mass or that element, divided by the compound's own total mass, times 100. Converting each percentage into a mole ratio, dividing by that element's own atomic mass, and then dividing every result by the smallest value obtained genuinely gives the simplest whole number ratio of atoms. This simplest ratio is the empirical formula. If any of these ratios come out close to a simple fraction like 0.5, all the ratios genuinely need to be multiplied by the same appropriate small whole number, 2, 3, and so on, to clear that fraction completely. The empirical formula genuinely gives only the simplest whole number ratio. The actual molecular formula could genuinely be that same ratio, or any whole number multiple of it. To determine which multiple actually applies, you genuinely need the compound's own molar MASS, found separately often through vapor density measurements. Dividing that molar mass by the empirical formula's OWN mass genuinely gives a whole number n, and the actual molecular formula is genuinely n times the empirical formula, applied to every single subscript throughout. The single most frequently tested G skill here is genuinely converting carbon dioxide and water masses back to their original carbon and hydrogen masses correctly, using the specific mass fraction or carbon within CO2 12/44 and or hydrogen within water 2/18. Forgetting these specific conversion fractions is genuinely a common calculation error. A frequently tested trap involves genuinely stopping at the empirical formula when the question actually asks for the molecular formula. Always check whether molar mass information was actually given, and if so, complete that final multiplication step. Also remember that if the calculated carbon and hydrogen masses together don't actually account for the compound's entire original mass, the remaining mass genuinely represents oxygen, or possibly nitrogen or a halogen, if the problem's context specifically indicates their presence. Let's recap. Combustion analysis burns a known mass of organic compound completely, converting carbon to CO2 and hydrogen to H2O, which are captured and weighed separately. Converting those masses to percentage composition, then to mole ratios divided by the smallest value, gives the empirical formula. Dividing the compound's molar mass by the empirical formula's mass gives the multiplier n, and multiplying every subscript by n gives the molecular formula. Correctly converting CO2 and H2O masses back to C and H masses is the key skill this topic tests. That's the determination of empirical and molecular formulae by the combustion method. Keep the CO2, 2 carbon and H2O to hydrogen conversion fractions sharp. They're the fastest way to handle these formula determination questions on the exam. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.